Now students, here's the turn for question number 32. Moles of chlorine produced during the electrolysis of aqueous solution of sodium chloride by the passage of current of 0.965 ampere for 1000 seconds is. In this question, current you have, time you have, and what's the process? The process is electrolysis of sodium chloride that results in the formation of two gases. At anode, chlorine gas is formed. At cathode, hydrogen gas is formed. But the question is based on the formation of chlorine gas. You need to find out the moles of the chlorine produced there. First of all, we need to understand here what is the process that's taking place. We know that in sodium chloride, chloride ions are moving towards anode and they are responsible for the production of chlorine gas. So what happens here? Chloride ion you have and you need to just produce chlorine gas from it. So 2 mole of chloride ion you need to take to give you 1 mole of chlorine gas, and now the total number of the electron, moles of the electron which are involved during this process are 2 mole. So simply we can write for the formation of 1 mole of chlorine gas, 2 mole of electrons are involved in this particular process. Now, here we need to just find out first of all the equivalence of chlorine. So, how do we calculate? Those would be equal to IT by F. The I value is already given in the question, 0.965, time is 1000 seconds, and then just divide this by Faraday's constant 96500. Now this value is equal to 0.01. So these are the equivalents of the chlorine. Now the next thing to calculate here is the final value, that's the moles of chlorine. What is the relation between equivalence of a particular substance and its moles? Very simple relation is there, that if you just divide the equivalence by the n factor, you will get the number of moles. So number of moles I just want to find out, equivalence I already have, and divided by the n factor that you already used during the process of conversion of chloride ion into chlorine gas. 2 electrons were used there. Number of n factor is there is 2. So I'm just divide this by 2. So these are the moles of the chlorine gas. On the basis of this, if we check the options given here, where that value is given, 0.01 divided by 2. That is correctly given here in option 2. 5 into 10 raised to the power minus 3. So this is my correct answer. I'll just mark it. Option 2. Right? I hope it is clear. Now the turn is for the next question. Question number 33. The standard reduction potentials of 3 metals A, B and C. We have the 3 metals, those are given here, and the values of their standard reduction potentials are these: 0.41, then 0.2, that's negative value, minus 0.2 and minus 2.17 volt. So if I just arrange them in the order of the decreasing standard reduction potentials value, in that case maximum value is 0.41, then is a turn for minus 0.2 and then for minus 2.17. It means maximum value is there for A, then for B, then for C. So this is the order of standard reduction potential. And what is asked in the question? To arrange them in their oxidizing power. With the help of standard reduction potential values, we can find out the oxidizing power also. More the standard reduction potential, more would be the oxidizing power. Yes, on the basis of this, A would have maximum oxidizing power because its standard reduction potential value is maximum. Then is the turn for B, and then is therefore C also. I'll just highlight this because it is clearly representing the order of oxidizing power. Clear? It's very simple. On the basis of this, we can easily choose the correct option. Where it's given? Yes, it's correctly given here in option 1 only. So, if you have chosen this question, this option as the correct option, then definitely you are going to get the marks. Next is a turn for the question number 34. We have this question given here on the board. Unit of molar conductance is, molar conductance, how this is represented? Lambda m, that is equal to kappa. This is specific conductance, and what is its unit? It is Siemens centimeter inverse. Further multiply 1000. The unit is centimeter cube per liter, because I am just going to divide this by molarity. The unit of molarity is mole per liter, right? On the basis of this, what would be the unit of this molar conductance? Definitely, the unit for this becomes Siemens centimeter square. Here, this is centimeter inverse, this is centimeter cube. So, it becomes centimeter square, and then there would be the unit that is mole inverse. This one. Where this value is given? Yes, it is correctly given here in option 2. So, it's your turn to identify it. Option 2 is my correct answer. Now, the turn is there for the next question, that's question number 35.